I'll be teaching you calculations on mass-mole volume relationship. That's about stoichiometry of a reaction. We've got this very first question here on the board. I would like to read it. Calculate the number of moles of calcium chloride that can be obtained from 25 grams of limestone, CaCO3. Limestone is calcium trisulfide 4. In the presence of excess hydrogen chloride. Did you get a question? We are to calculate the number of moles of calcium chloride that we can get from limestone. So we have business with calcium trisulfide 4 here, which is the limestone, and we have business with calcium chloride. It is the number of moles of calcium chloride that we are to calculate. But you know that what is producing the calcium chloride is limestone, which is calcium trisulfide 4. So these two compounds are our focus in this question. However, how do we obtain this calcium chloride from limestone? Here we are told that it is in the presence of excess hydrogen chloride. That simply means that hydrogen chloride is going to react with limestone, calcium trisulfide 4. And then in the reaction, we expect that calcium chloride will be obtained in the product. Hence, we will write the reaction equation. Is that okay? So I'll write the equation for the reaction. This is the reaction between calcium trioxocarbonate 4, is a solid, which is limestone. It's going to react with excess hydrogen chloride. This is aqueous, alright? Now let us see the product that we are going to get. You come to this. We have a metal which is positive here, a metal ion which is positive. That's calcium. It's going to react with a negative ion from here. And the negative ion in this hydrogen chloride is chloride ion. Now if calcium is reacting with this chloride ion, we expect to get calcium chloride. Please visit our video on valency and you'll see how we can be able to write the correct chemical formulae of a compound. I've taught you that from previous classes already. So we expect to get calcium chloride, and the correct chemical formula of calcium chloride is CaCl2. Is a solid. Then plus, we have carbon, oxygen left, and then hydrogen from here. This oxygen will react with hydrogen to give us water. And you know that the correct chemical formula of water is H2O. I'll put liquid. Now we are left with carbon and 2 oxygens. The carbon and oxygen will react to give us carbon dioxide, CO2. This is a gas. I've written the chemical equation, the products that will be formed, and I wrote the correct chemical formula of the product. But I don't know if this reaction is balanced here, so let us look at it. In the product side, calcium is 1. In the reactant side, calcium is 1. In the product side, calcium is also 1 atom there. Carbon is 1 in the reactant side, and carbon is 1 in the product side. Oxygen is 3 in the reactant side. Let's look at the product side. In water, we have 1 atom of oxygen, and then in carbon dioxide, we have 2 atoms of oxygen. If you add 1 to 2, you get 3 of oxygen in the product side, so it balances. Let's come to hydrogen. Hydrogen is 1 atom in the reactant. In the product, it is 2 atoms, so we need to do some balancing. Alright? Then chlorine is 2 atoms in the product side, but in the reactant side, it is 1. So you see clearly, hydrogen is 2 in product, chlorine 2 in product. In the reactants, hydrogen and chlorine is 1, 1. So clearly, we are meant to put 2 here to balance it out. But remember, when I taught you balancing of chemical equation, you can choose to find out by solving. So let me just do a quick one here. If I said, okay, hydrogen is 1 in the reactant side and 2 in the product side, you will now have to add an unknown in the side that has fewer number of the atom, which is X that I've put here now, you know. Then I'll do X mole times 1 atom of hydrogen in the reactant. We have X times 1. I'm working for hydrogen now, okay? X times 1 in the reactant will now be equal to, in the product side, 1 atom of hydrogen times 2. Or 1 mole of hydrogen rather times 2 atoms. You have 1 times 2, and then X will give us 2. So do you see clearly that this X is equal to what? 2. I'm going to write 2 there for you to see. I'm using blue marker to show that we did a balance in there. And you see that automatically chlorine balances. Because whatever number that affects hydrogen will also affect chlorine in hydrogen chloride. Because the valency of hydrogen and chlorine is 1, 1. You know, please visit valency video or the notes to refresh your memory on this. Now that I've done this, I'll now focus on the 2 compounds of interest. One of them is this limestone, and the other is calcium chloride. We are to determine the number of moles of calcium chloride that this limestone, 25 grams of limestone, will produce. So I can write out the stoichiometry of these compounds. But before then, let me just bring out the 2 compounds of interest. We have calcium trisulfide 4 giving us calcium chloride. Now the stoichiometry. The stoichiometry is simply 1 mole ratio 1. 1 mole ratio 1 mole. What do I mean by that? If you look at the reaction equation, you notice that limestone or calcium trisulfide 4, 1 mole of it is what produced 1 mole of calcium chloride. That's the meaning of the 1 mole is to 1. Is that okay? Now, let us visit our question back. Calculate the number of moles of calcium chloride that can be obtained from 25 grams of limestone. Did you take note that the units of the value of limestone given to us in the question is in grams? Therefore, the mole of this calcium trisulfide 4 in this stoichiometry, I will change it to gram. Now, by standard, according to the stoichiometry, 1 mole of limestone, calcium trisulfide 4, will give us 1 mole of calcium chloride. So let us convert this 1 mole to molar mass of calcium carbonate so as to get the value in gram. All you have to do there, calcium is 40, you add carbon, which is 12, then you add 16 times 3 for oxygen. Exactly how you calculate molar mass. We've done that in our previous classes. If you do that, you're going to get that 100 grams of calcium trisulfide 4, that is limestone, will now give us equal to 1 mole of calcium chloride. 1 mole of calcium chloride. 1 mole of calcium chloride. Again, this is the standard. This is the stoichiometry. We know that 100 grams of calcium trisulfide 4 will give us 1 mole of calcium chloride. Therefore, 25 grams will give us what? 25 grams of limestone. How many mole of calcium chloride will it give to us? Do you know the reason why I did not convert the mole of calcium chloride to gram, just like I did to that of limestone? I did not convert this mole of calcium chloride to gram because the question is we should calculate the number of moles. So for calcium chloride, we are still looking for moles, so no need of converting to gram here. Why I converted that of limestone to gram, 100 grams, there is because the number given to us in the question for limestone is in gram. If in the question we are asked to calculate the number of mass, the mass of calcium chloride that will be obtained, then I will have to convert the mole of calcium chloride to mass using the molar mass. Okay, now here I would say it implies that 25 grams of limestone, calcium trisulfide 4, will give me, I don't know, question mark. I do not know the number of moles of calcium chloride that can be obtained from it. That is what I'm looking for. At this point, I will do cross multiplication. Let me show you. You do cross multiplication, something like this. If you like this question mark, you can say, let us call it X. Say, okay, let 25 grams of limestone produce X mole of calcium chloride, and then solve for X. If you cross multiply, but first you see that this gram and this gram will go off. All this will go off. So if you do your cross multiplication, you will see that 25 grams of calcium trioxocarbonate 4 will now give us 25 times 1. 25 times 1 mole. 1 mole of calcium triocarbonate, that is calcium chloride rather, then divided by 100. Divided by 100. You know, if you have done 100 times, say this is X now, equal to 25 times 1. Solving for X, X will be equal to 25 divided by 100. You know that. That's what we are doing there. Okay, so in conclusion, let us find the value of this. 25 divided by 100 is equal to 0.25. So it is equal to 0.25 mole. Therefore, 25 grams of calcium trisulfide 4 of limestone will produce 0.25 mole of calcium chloride. And this is our answer. So you can see, very simple. Now let me summarize something here, okay, because this calculation is a simple one. It is just like somebody saying that one biscuit is sold for 10 naira. Therefore, buy 3 biscuits. How much do you think that 3 biscuits will be sold? To be sold for 30 naira. And how do you know that it's 30? In one of our previous classes, I've shown you how to interpret that mathematically, and that's what I did here. Are you following, right? Very simple. From the stoichiometry, 1 mole is equal to 1 mole here, which means 100 grams of calcium carbonate to give us 1 mole of calcium chloride is a standard. Is a standard. Just like saying that 100 grams will produce 1 mole. Therefore, 25 grams of that limestone will now give us, we don't know. Cross multiplying is solved. We're going to look at yet more questions on this.